Hi, this is a tutorial using the KISS framework on how to use objects and tie them together using a common pattern called an events model in the KISS framework using some very simple objects. So if you have no introduction to objects yet, go listen to the tutorial on objects, and then here are a few objects here that will help us get us started. So this is a slightly new concept. Well, new concept. Enum stands for enumerated. So if you have a list of things like days of the week or something like that, which you want to have in your application and think about a convenient feature in Java for keeping track of a set of things that are a short list of essentially constant ideas is an enumerated thing. So we're having an enumerated state which can either be on or off, and we can use that to keep track of on or off things. So a good, so perhaps no surprise, then a light should be that sort of a thing. So a light, just to keep track of it for our messages below, we're going to have a string that lights have called location. So location is part of every light. And when I make one, this is called a constructor. So when I construct a light, I hand in a location. Everybody has slightly different habits. Mine is to just put an underbar in the name just to distinguish the thing that gets handed here from the location up here. And so when I create a light, I'm given a location, and I use that to just update my internal location. So this way this light knows where it's at. And so that's the way I make a light is with this constructor. So this is a method, and the name here is actually fairly important. So in order to have lights communicate with other things, I have a method called onReceive, and then the name of the thing that gets handed around. In this case, since it's a state, it's onReceive state. It doesn't have to be the thing that gets handed around doesn't have to be a enumerated type, although obviously that would be fine. Could be a different class, for example. It somehow summarizes information that you want to hand around in your application. But light, in this case, receives state, some kind of state, which is apparently an on or off. And right now, all we do is have a print light in the location where we remember where it's at is, and then this would either be off or on, depending on the state. And then here's a test. So to see how lights get tested, well, we'll make a light that is apparently in the attic. So this is the notation for building a light. So you use the new operator, and because the constructor needs a string, we have to hand a string to it. So attic will be the location of this light. And then here's a typical test. So we should hear or expect light in attic is off if we invoke this method on receive state and hand off state.off. So that if we want this off state, if we send to the light that we just made, if we send off the off message or the off state to it, then we should hear back from the print statement light in attic is off. And then of course if we send an on message, we should hear light in attic is on. So those are the sorts of things that lights should do, and those are the tests for that. Okay. And then from the previous example, I wanted to create something that really didn't have anything to do with state, and this is actually important because this happens a lot when you're creating objects, is kind of how do you glue the pieces together. So here's a puppy that happens to awaken, and when you awaken it barks, and when you want to, and here's a little test of how puppies work. So you make a puppy, you can make a puppy that way, and you would expect a bark if you ask it to awaken. So here's a little tested puppy in here. With just a single method and no constructor, because there's nothing to really build in that case, so that's pretty easy. Alright, so this is a thing that will then help us glue pieces together. Alright, and skip the tests for the moment, just look at what the methods you have. So remote, think of it like a little remote control. Imagine that you had a little button by your bedroom or something like that, that when you press it, not only turn on your lights in your room, but turn on the lights in the whole house, kind of a panic light or something like that. So a remote, if you want to have it take care of handing state around to other things, then it's something that can generate state messages basically. And so in the KISS framework, what you do is you say that that remote extends a generator of a state. So state was that enum up at the top. You scroll back up to there. So it's just one of these guys, off or on. It could be any class, including an enum like that. But in our case, we're just going to hand around on or off messages basically. So remotes can hand around on or off messages. And in order to do that, here's the two things that remotes can do. You can press the on button and you can press the off button. And the implementation of on for remotes is if anybody's listening, then go ahead and send an on message to everything that is listening. This is features that you get out of saying you extend, you can say is you are. So remote is a generator of state. And so when you send on, listening is a feature of those generators, so it keeps track of whether anybody's listening. There's no reason to do any work if there's nobody listening. If somebody's listening, then go ahead and send off a message to everybody. And in this case, we'll send off the on message, right? For if somebody asks a remote to be on. For off, if anybody's listening, then we'll go ahead and send an off message. So how does this work? So since we have a light, let's start with light here. So let's test. This is how it might work if you're using a light, because lights apparently can receive states, right? All we need is the ability to receive a state. So we'll create some kind of remote. We'll call it just a little remote, and we'll create a light in the attic apparently. And then this is the little piece that ties these two together. So remote is a generator of things that can send state to other things, and light is something that can receive those messages because it has that on receive message. So from the remote, I'll just add a light, and so now this remote, the one I created right here, now knows that light, this light right here, this light is something that it is connected to. And so now, if I hit on the remote, that remote will send a message to the light, which is going back up to our light up here, which will then invoke this bit of code, the on receive state. So because they are now connected because of the add listener business, the on receive state will be executed, and then whatever lights do with on or off messages, it will get done. All right. And so here we created a light, we created a remote, we kind of plugged them together. So we added to the remote, told it that there's a light that is listening to it, and then now when I turn on the remote, in the end the light in the attic will get turned on, and so we should get light in the attic is on with a remote on, and we should get light in the attic is off with a remote off. So here's a little test that will test whether our remote is in fact controlling the light in the attic after we plug them together. So what's the big deal? So a common thing that happens in object design is you make these pieces, which are all very important and useful to test independently. What can be a bit of a hard thing to do is hooking those pieces together. And this event model is a pretty good model for hooking pieces together. So what happens then is some parts of your application generate messages, and in this case it's remote, all right, and then some parts of your application can receive those messages. In this case it's a light, and so then you can create as many lights and remotes as you need and wire them up in whichever way is useful to you. And then in the end when you turn when you ask the different generators to generate the messages, all the listening receivers will just do what they're supposed to do. And that's a really important decoupling of your infrastructure. So making a class is great. It helps a little isolated testing to make sure that that piece works. But then in the end, the pieces have to be put together somehow. And this sort of event model is a good way to plug pieces together that's convenient and safe. All right. So that's testing a remote light, and that's how that works. So so now, what is this funky little thing? Test remote lambda. So a lambda expression is a computer science term. Java supports it, and there's just times when you want to just do a little deferred step when an event happens. And in this case, so we created, here's the test. So we create a remote. Here's a different remote that we decided to create here. And to that remote, we added a listener, but notice it's not a light. What's inside here, that little bit in here, and this is a very common pattern you see in Java, is we're going to just add a little deferred action. So when this remote is activated, so whenever some send happens, this remote will just take that state and the action it will do, and this is not right now at this method, but when it's turned on or off, we'll take that action and turn it into a println statement. So it just prints out the state, which in the end prints out like before, on or off. Okay, and so this little convenient shorthand is really important because there's little one-off events and actions you want to take and account for, things like button presses, for example, or just events that happen during your application. And one of the most convenient notations for adding a quick, oh, when this happens, go ahead and do this, are these Lambda expressions. And so it's quite important to kind of see the notation and just appreciate that it's a very convenient thing. So it's analogous to, let's try to connect these two. So light has this built-in receiver, right, on receive state, and that is the thing that gets invoked down here every time remote sends some message. But up here, you don't have to build all that infrastructure if it is a simple thing. So our simple thing was, all I really want to do is print out the state whenever the remote changes. And so what I can do is add a listener and have that listener be the action that when I get a state, just print it out. And so this Lambda expression is essentially a deferred action that you can easily add, and is a common pattern you see in much of the event model of Java. And then here's a little test of that behavior. So once I've wired those together, when I turn the remote on, I expect this print statement to just print out on, and of course when I turn it off, I expect the print statement to print off. And so that's the idea of the remote. Maybe I should add, remotes can have as many listeners as is useful, so you could have one remote listen to many, many devices. So that's a tested little remote class. The key thing about this being a source of events is that it's a generator. So a generator of, and then whatever in this little angle bracket of the sort of things that it can generate. And the thing that it can generate can be any object or enum. So enum is actually a special kind of object. It can't be what's called a primitive type. It can't be like little I int or a double or something like that. You need a small class or an enum that gets sent around to have that work out. So, but once you decide what kind of messages you need, and you can have lots of different kinds of messages and lots of different kinds of generators. So, whatever message types you decide to create, then you can create different classes that generate those messages. And then once they have certain things happen, like someone presses the on button, I guess, on the remote, then here's the action that it wants everybody that's registered as a listener to do. So this thing's the generator side of things, and then here is a bit of a how that might work out in a little house situation. So here's my final app with those pieces all put together and tested. So bedroom light, test a light to make sure that does the things it should be doing. And then I make two lights, so I have a bedroom light and a kitchen light, so one's in the bedroom and one's in the kitchen. And just kind of randomly, but there's a lot of strong analogies to this. And there's a puppy, right? So this one doesn't have much to do with the other infrastructure, but oh yeah, there's a puppy, and puppies have something to do with what's going on as well. So bedroom light, kitchen light, and a puppy, all right? And then I'm going to make a remote and test it. So notice everything is tested in here, so all the test methods on those classes up above get executed and make sure that their behavior is what they should be. And then, so remote, add listener, bedroom light. So bedroom light is a light, and since lights have an on-receive state, that's exactly what gets invoked every time the remote sends a message. And then kitchen light is also a light, so it has an on-receive state. So that one's easy. But puppies have nothing to do with state. And so this is a simple example of a Lambda expression and what it might look like. So for this remote state, and then we're going to just say that if the state that gets sent out happens to be on, that's when the puppy wakes up. And so this little deferred action called the Lambda expression is how we hook up, oh, and then the puppy will wake up every time we happen to turn on the lights. So this remote, the one we create right here, has three things that are interested in it. So there's a bedroom light, a kitchen light, and then what in Java is called a lambda expression. And this lambda expression is deferred to when remote sends off messages. Well, the message it sends is going to be state, and then you do whatever you want with it. In this case, we check whether it happens to be the on state. If it is the on state, then we'll go ahead and wake up our puppy up here. So those events happen, and then here is then how you would expect it to work. So if I now ask the remote to turn on, and then in this order we should see these things happen. So first the message is first sent to the bedroom light, so then light in bedroom is on, and then the message to the kitchen light is sent, so light in the kitchen is on, and then finally this lambda expression is executed, which since it's an on case, we should hear a bark from the puppy. So those are the three things we expect to come out of asking that remote to turn on. And then if we ask the remote to turn off, if we hit off on that remote, then, well, puppy doesn't do anything, right? Because this only happens if the state's on. So the only things we hear is that the light in the bedroom and the light in the kitchen are turned off. And that's exactly what happens. So if we hit execute in here, all the tests pass. And notice we test the house, we test the light, we test the puppy, we test the remote light, and we test remote lambda, and finally the end of the test of the house. So all those components got tested, and they all behave exactly as we expected them to. And so that's a nice illustration of what's called the event model, which is used a lot inside of Java for good reasons. It helps you plug together different pieces that solve different problems and have them work together with just sort of one sort of wiring step. So right in here, this remote add listener business, and this with a relatively small amount of code, you can take different objects and essentially connect them together so that, oh yeah, when this happens, then that happens. So the key idea then is you have elements that will receive those messages. They can do it explicitly because of an on receive of some particular type like this. Or using the lambda expressions, you can really wire in almost anything. So here's a puppy that has nothing to do with messages that in the end we made it do something anyways. So you need potential receivers, and then potential generators, the ones that generate those messages, and those classes need to extend generator of the message type that you're interested in having sent around. One application can choose to send out many different kinds of messages. They just have to extend the messages of each of the different types. And then remote only has to worry about actually choosing how and what to send in particular, depending on what it is. And the other side then just has to worry about receiving them. And then this generator then worries about wiring them all together. So the generator makes all the wiring happen, and you can just work in the application space of those things being connected. And so a lot of applications end up creating a certain amount of infrastructure, hooking those pieces together through listeners of different kinds of message types, and then just letting them interact with each other as they send messages from different sorts of places. So the event model is a very useful thing, and now you have a small amount of infrastructure to see kind of how it works and some of the core components.